Today's lesson is based on momentum. We are going to look at impulse. This is lesson 103. Let us start. Impulse is another way to define momentum. Impulse is a measure of the amount of force applied to an object for a certain period of time. This is the equation which defines impulse. Now let us look at the derivative of this equation. The derivative of this equation, it comes from Newton's second law. F net is equals to ma. We all know that acceleration is equals to the rate of change of velocity. This simply means that A is equals to Vf minus Vi over change in time. So where we see A, we can substitute by this from this equation. So we are going to have F net is equals to M change in V over change in time. Further simplification, we are going to have M change in V over change in time. Then we cross multiply, or we multiply each and every term by change in time to get rid of the denominator. So F net multiplied by change in time, it's equals to M change in V. Then we know that M change in V is Vf minus Vi. From the previous lesson videos, we actually know that change in displacement, change in momentum, is equals to M Vf minus Vi. So F net change in time, it's equals to, this is equals to change in momentum. So we have this equation. Change in momentum is equals to impulse. Impulse, it's F net change in time. Suppose you have this scenario. We have a ball moving towards a wall at 12 meters per second. The mass of the ball is 175 grams. After hitting the ball, it goes in an opposite direction at 7 meters per second. And then the contact of the ball, the ball makes contact with the wall for 0.05 seconds. So the duration of contact is 0.05 seconds. Calculate the impulse of the ball. Now we are going to use F net change in time, change in momentum. Like I said, this is the impulse, so we can just calculate the change in momentum as usual. We have M Vf minus Vi. The mass we convert to kg by dividing by 1000. It's 0.175. We divide by 1000. Final velocity, it will be -7 since it's moving to the opposite direction, and then minus 12. The impulse of the ball is -3.325. Now, what is the SI unit of impulse? It's the combination of force, which is Newton, and then time, it's seconds, so it's Newton second. Not Newton per second, it's Newton second. You can see that the impulse is also a vector. Furthermore, the question: calculate the force exerted on the ball by the wall. We are looking for the force, so we are still going to use this equation. Since we have this, we need the time, the duration of contact, and the change in momentum. So it's F net negative 3.325. Then we divide both sides by 0.05. This will result into 1 multiplied by F net. We have F net is equals to negative 66.5 Newton. So you can see that this negative, it simply means that the wall exerts a force on the opposite direction to the ball. Now, just to explain Newton's third law, another question might appear that what is the magnitude and direction of the force exerted by the ball to the wall? Now, action-reaction, it simply means that the ball exerts a force of 66.5 Newton this direction, and then in reaction the wall applies an oppositely directed but equal magnitude on the ball. So this is how we use the equation of impulse to calculate unknown physical quantities. That's it for this lesson video. This is Bahula SJ. Thank you very much.